Section 5.4, Addition and Subtraction of Polynomials. To add polynomials, add the like terms. Like terms have the exact same variables raised to the exact same exponents. So if we want to add 2x squared minus 8x minus 7 and negative 4x squared minus 3x plus 11, we want to add the like terms so they have to have the same variable with the same exponent. 2x squared and negative 4x squared are like terms. So let's add them. You have 2 of them minus 4 of them. You have negative 2x squared. Minus 8x is like term with minus 3x. If you have minus 8 of them minus 3 of them, you have minus 11 of them. And finally, you have this minus 7 plus 11. Minus 7 plus 11 is plus 4. Sometimes I like to explain like terms in terms of fruit. People make fun of me, but I don't care. So if you have an apple, that's x squared. If you have an x, that's a banana. So our first like terms are both apples. You have 2 of them minus 4 of them. You have minus 2 apples. Notice that when you add apples and apples, you get apples. The x's are bananas. So you have, I need to get a banana color here. You have minus 8 of them. You have minus 3 of them. So you have minus 11 bananas. Notice that you combine bananas with bananas, you get bananas. If you add x's with x's, you get x's. Don't change fruit. Sometimes people try to add x plus x and get x squared. That's like adding a banana with a banana and getting an apple. Doesn't make any sense. So keep the same fruit. And finally, you have minus 7 plus 11. That's plus 4. So now let's look at these like terms that we're trying to add. Remember, in order for it to be a like term, in order to add it, it has to have the exact same variable raised to the exact same exponent. This is 2a squared. Do you see another a squared? There's an a squared. Those are like terms. When you add 2a squared minus, there's no coefficient there, but it's minus 1a squared. 2 minus 1 is 1. So you just have a squared. What about minus 3ab? Is there another ab? There's one. And there's one. So we have minus 3 of them, minus 6 of them, that gives us minus 9, plus 5 gives us minus 4ab. What about the b squared? 5b squared, 7b squared minus 8b squared. 5 plus 7 is 12, minus 8 is 4, plus 4b squared. That's our answer. We combined all the like terms. We started off with a squared terms. We still have an a squared term. An ab, we've got an ab term. B squared terms, we combined them, and we got 4b squared. The text talks about adding and subtracting polynomials vertically. You won't be asked to do this in this class. However, if you choose to do it that way, you may. So, find the sum of these two vertically. What it means vertically is just write them one under the other, making sure you line up the like terms. So our first expression is 5x squared minus 3xy minus 4y squared. We want to add to that 2x squared. It is like terms with 5x squared minus 6y squared goes under the minus 4y squared. So to add vertically, you line up the like terms. It makes it a little easier. That gives you 7x squared. The 3xy didn't have anything to combine with, so it's minus 3xy minus 10y squared. And that's your answer. I actually think adding and subtracting vertically is a little bit easier, so you can line up your like terms. To subtract polynomials, you want to change the sign of each term of the polynomial that's being subtracted, and then you want to add. So let's subtract 4x minus 7y from 3x minus y. So 3x minus y, and we want to subtract from that 4x minus 7. Notice it's kind of said backwards in the problem from what we write down. Subtract 4x minus 7 from 3x minus 5. So the first thing we want to do is we want to realize that we're subtracting 4x, but we're also subtracting negative 7y. Subtracting a negative is like adding a positive. So that's the same thing as plus 7. That subtraction changes the sign of everything inside the parentheses. So it makes this minus 4x plus 7. Then we combine our like terms, so we have minus x plus 2. And that's our answer, minus x plus 2. Here we have another one. It's already set up as a subtraction problem. The first set of the parentheses isn't really doing anything, so we can just copy the problem down without parentheses. Now the second polynomial is being subtracted, so you change the sign of every term. So it's minus x3, it's minus 6x squared, it's minus 9x, and it is plus 5, because you're subtracting a negative 5, which is the same thing as adding a positive 5. We're looking for like terms. We have minus 2x cubed minus x cubed, that's minus 3x cubed. We have minus 4x squared minus 6x squared, that's minus 10x squared. We have plus 7x minus 9x, that's minus 2x. And we have minus 1 plus 5. That's going to give us plus 4. And that's our answer. Oh, this problem has lots of things going on. You're adding 2x squared minus 7x minus 8. You're subtracting this polynomial, so you better change the sign of every term, so it's minus 5x squared plus 3x minus 4. Then it's plus 4x squared plus 2x. So let's identify all of our x squared terms. 2 of them, minus 5 is minus 3, minus 3 plus 4 is 1x squared. Minus 7x plus 3x plus 2x is minus 2x. Minus 8 minus 4 is minus 12. And that's it. That's our answer. We're subtracting here minus 3y cubed plus 2y minus 7y plus 4 minus 2y cubed minus 4y squared plus y. Let's look for our like terms. Minus 3y squared cubed minus 2y cubed is minus 5y cubed. Let's see, we're looking for y squares. There's only one, so it's minus 4y squared. What about the y's? No y's around here. 2y minus 7y is minus 5y, plus y is minus 4y. And finally, plus 4. And that's our answer. let's evaluate this polynomial, 2x squared plus 2xy minus 5y squared, for x equals 3 and y equals negative 2. So 2 times 3 squared plus 2 times 3 times negative 2 minus 5 times negative 2 squared. Let's see, that gives us 2 times 9. You know, exponents have to be handled before you can do multiplication, division, addition, subtraction. We can go ahead and do this multiplication. 2 times 3 is 6, times negative 2 is negative 12, minus 5, negative 2, that's the quantity negative 2, squared, which gives us a positive 4. So that gives us 18, plus the negative 12, we could just write as minus 12 if we want, minus 20. So 18 minus 12 is 6, minus 20, negative 14. And that's our answer. The number in thousands of male commissioned officers in the U.S. Department of Defense in a given year is approximated by the polynomial negative 0.1 x squared plus 5.4x plus 18.3, where x represents the number of years since 1940. The corresponding polynomial for female commissioned officers is 0.2x plus 1.3. Find the polynomial that represents for a given year how many more male commissioned officers than female commissioned officers there were. So the polynomial we're interested in, let's call it P of x, is going to be the males minus the females. So it's going to be negative 0.1 x squared plus 5.4 x plus 18.3 minus the females can be found with the polynomial 0.2x plus 1.3. We can simplify that. Let's go down into the next blank space here. Negative 0.1 x squared plus 5.4x plus 18.3 minus 0.2x minus 1.3. Let's combine our like terms. Negative 0.1 x squared, no like term for that. We have two x terms, that'll give us plus 5.2x, and we have 18.3 minus 1.3 will give us plus 17. So that's our polynomial that's going to tell us the number, how many more male officers than female officers there are. We want to know in 1970. So x represents the years since 1940. What's 1970 minus 1940? It's been 30 years since 1940 in 1970. So we want P of 30. So we're going to take negative 0.1 times 30 squared plus 5.2 times 30 plus 17. Let's put that in the calculator. You have to turn the calculator on first. That gives you 83. In 1970, this polynomial predicts that there were 83 more males than female officers. That's it for this section.